Okay, sorry, me again. This time I'm going to talk about object and actor-oriented programming. So over the next 40 minutes, I'm going to give a high-level overview of what OOP is, object-oriented programming, and also actor-oriented programming. In the next 40 minutes, I'm not going to teach you how to do it. It's more what it is, and then I'll show you some resources into the actual right-clicking to create an actor or a class, and take you through that. So I split this into two presentations. The first one will be object-oriented programming, and the reason why I really like object-oriented programming and why I believe it's one of those programming concepts that should be taught as a fundamental. Because object-oriented programming isn't this big scary thing which somehow in the LabVIEW community it's been taught to be. No, OOP is essentially a different way of thinking. Let's take you through an ideal situation. And so you have a kick-off meeting with your customer, and they have all of their requirements already, and they know exactly what they want. I mean, obviously not in real life, but this is an ideal situation. And you go, excellent, I know exactly what I want, so I'm going to go away and actually do some LabVIEW. This is the fun bit, it's just playing around with LabVIEW. You then deliver your code, and your customer is really happy. And the only thing more valuable than a happy customer is a happy developer, which is you. In fact, the customer is so happy, they get on the phone and say, hey Tom, really like your code, here are some more requirements. And so I'm like, yes, I built up a good rapport with this customer. And so I take those requirements, I sit down and add the extra functionality. Ooh. And now I... Is that...
Sorry about that, we'll edit that out.
No, that's right. I was thinking that's a really feeble fire alarm. I don't know what's going. Okay, so new requirements. We do those new requirements, and yes, we have a really happy loyal customer. However, there's one stage in here which really trips developers up, and it's this one here. This stage of adding extra functionality or extra hardware support. It is at this stage where you'll be at your computer really confident because you did a great job the first time. Then you look at your code to change it and you think, oh, Tom, why did you do that? You realise all of these mistakes, you didn't follow all of the correct practices, you weren't listening to Fabiola when she's shouting at you to use VI Analyzer, and so it's at that point where you realise why you follow these good programming practices, but it's also at this point where you realise, I should have made a more extensible framework. I should have used a programming technique which allows me to append functionality instead of changing functionality. Because we could have a piece of code like this, and it's really well written, it will probably pass VI Analyzer, everything has a label, there's documentation, nicely spread out, and it's for an Agilent, for an Agilent 34,000 series VML. But your customer now says, oh, hang on, we've just got a load of extra funding, so we've put in a PXI chassis, could you make it work for a 4080 month as well? And you're looking at this code thinking, I'll do it because you're paying me, but it's not going to look pretty. And you end up with these case structures, and it's not very scalable at all. So the theme of the first part of this presentation is all about future-proofing your code, making it so you can extend the functionality of your code without actually changing your code. Because I've had loads of one-to-ones with my main customer, who happens to be my manager, where just before a one-to-one, where I review what I've been doing for the last few weeks, I want to change something really quickly, to like make it extra impressive for my manager. I change it, then suddenly it doesn't work, and then my Outlook pings up, and I have to go into the office and say, I promise it was working, but it's not anymore. Whereas if I hadn't changed that code and I just appended some extra functionality, it would have worked. Because all of that code is already tested. I remember. Okay, so your object-oriented programming, or OOP, solves the issue for me. It's not everyone's cup of tea, but with the OOP mindset, we're going to be thinking about these items, these things, as classes. So we could think about a class is anything you know something about. And those classes can encapsulate the functionality and the resources required to execute that functionality. Let's look at this piece of code, for example, in a very abstract manner. We have an Agilent DMM, which we want to collect data from and store it in a CSV file. And so, really straightforward piece of code. However, it's not particularly future-proof, because sooner or later, your customer is going to realise that CSV files are awful and inefficient. I'm a few slides ahead of myself. And so they go over to a TDMS file, which is just a binary backend. And then they got their budget upgrade, so they went from an Agilent DMM down to, what was it, a 4081 PXI card. And now you have a customer who wants to use either a CSV file or a TDMS file, and they don't really know whether they're going to use an Agilent piece of equipment, an NI piece of equipment. Perhaps they don't have any equipment yet, and they need a simulated piece of equipment. So we want to have any combination of these. Object-oriented programming allows us to implement these different combinations. On the board here, we can see a class, and it has a little blue cube in your Project Explorer. You have your class name, in this case is XML, for just a markup language wrapper API. And this class has some private data as well. So this private data, we have a document object model reference inside of it, and this is a reference to the actual file itself. But notice how there's a little red key next to that data, next to that control. That key means only functions, so only VIs or controls within that class can access it. Which means if there are any issues with the XML, perhaps that reference becomes invalid. You know that the only people, well, the only methods using that reference belong to the class itself. So you immediately know where to target your troubleshooting. Perhaps in CreateTag, you're not wiring your reference out. Or perhaps you've got to use defaultive unwired box selected instead of wiring the reference straight through. In object-oriented programming, we have these methods, and those methods are just VIs, where we can right-click a class, go to new, then we could create a VI from a template. Those VIs, which I'm going to start calling methods, can perform some functionality using that private data. The private data we can see here, and we can treat this object. So an object is just a class you see on the block diagram. An object is the wire. We can unbundle the object and get to that private data. We could also do it in reverse, use the bundle by name function to bundle into the object. So methods can use this private data to perform functionality. And by encapsulating this functionality and the private data together, we make a really nice API, application programming interface. This API, we can open a file, get data out of it, view the entire contents of the file, close the reference, and then check for errors at the end. But with this API, we're just abstracting. We're not looking at the individual property nodes and invoke nodes you need for the XML file. We're simply putting down methods called getData, setData. This APIs written using classes lend themselves really nicely to being packaged. So if you package a class using the JKI VI package manager, you can really simply add those to your tools palettes. And so I have loads and loads of reuse libraries based on object-oriented programming, which I find in my tools palette. And it speeds up development no end. And so you can see, just by using the functionality of object-oriented programming, which is a cluster that you can pass from method to method, I get great benefit out of that. It's easier to debug, it's better to test, you can package it into a nice code reuse library. But there's more functionality you can add. Let's take, for example, both of these DMMs that you see here, they both need to be initialized. However, the way we initialize them is going to be different. However, it's not going to be clear until runtime, until the user actually opens up the software. The software will realize, oh, it's an Agilent DMM that's connected. Oh, it's a NI DMM. Oh, actually, I need to simulate a DMM because neither of them are connected. So we need to come to something called inheritance, where we can think about these classes in a very abstract manner. We can think, oh, in this piece of software, I'm going to have a digital multimeter, and that digital multimeter is going to initialize. It's only later on where we get budget approval for, let's say, the Agilent DMM, where we create another class and have it inherit from that abstract class of DMM. Once we have that abstract class, once we have that child class, we can then add in that functionality. Let's take this as another example. So this is an application where I'm just going to stream images from a file, or I'm going to use my laptop webcam, depending on which option the user selects. However, we're not going to know until runtime if we're going to run in simulation mode or in webcam mode. So when we write the software, we can just write the software to work with a camera. We don't know what this camera is, we don't know which brand or make or model, we're just thinking camera. And all cameras have to initialize, they have to start acquisition, they need to get images, they need to clean up any references. So we can stick those up in the camera class. It's only when we go down a level to the child classes of webcam where you realise, actually some of the data we need for a webcam will be an iMac DX session reference. So we can now start to append some data to this class. We're appending this session reference. And we're doing something called overriding functionality. So you can override the initialize, start, get, and clean up camera functions. Whereas over on the simulation side, we're not doing that. We don't need to initialize, get Windows to warm up itself to open a file. No. I've just overridden the get image for the simulation class, and that's all I need to do. It's just reading an image from file. Okay, let's just have a very quick look at that in action. Okay. here, I have two objects. I have a simulation object, so I'll use the cursor here. I have a simulation object, which is this object here, and I have a webcam object, which you can see here. And it's only until runtime where LabVIEW is going to know, oh, should I pass in this wire or should I pass in that wire? And then the functionality of these VIs is going to change. Now let's just see it in action, and then we'll have a look at some of the code. So if I run this VI, I can choose to enable simulation mode and click run or play. And I'm just opening up some really low-res images, but I'm just loading images from file and displaying them on the screen. I stop that. If I take this off simulation mode, if I run this, take it off simulation mode and run, okay, you can see that my webcam has kicked into action, like you can see on the display. So you can see there are two very different bits of functionality going on here. And it was only until runtime that we actually saw what was going on. If we have a look in the project, so Control-Shift-I to open up the project, underneath camera, we have these methods. And these are the methods which we dragged onto the block diagram. And you can see they're green, the same as these methods down here. Those methods are going to be overridden depending on which object is passed through. So if we pass through webcam, it's actually these methods which will execute. Even if we pass in simulation, notice how there's only one method here. So when we simulate, we're going to execute initialize, start acquisition, and cleanup out of the camera class, but simulation just gets the images. And we can see that on the block diagram as well, but if I double click, LabVIEW doesn't know which implementation to open up because we're not running. So in the, which VI? Yeah, this is the get image VI. So when we simulate, we're opening an image from file. In the webcam class, which function is that? We're extracting an image from the webcam. Okay, is everyone following me so far? Perfect. And the code I'm showing you there is available on my GitHub page. I'll put a link to that in the end. Good, I'm glad you're following me so far, because now I'm going to take it up a level and talk about the actor framework. Now, a lot of the time when I talk to people about the actor framework, or I bring up the topic, or I say, oh, this code is written in actor framework, this is their reaction. They're like, oh, I don't know what that is. It's something to do with OOP and actors and something. So I want to take it back right to the beginnings of what an actor is. In fact, can someone here tell me what an actor is?
I think it's an asynchronously running process which accepts messages and requests, and it chooses to do what it wants to do.
Yeah, perfect.
You've learned that.
So the first
So
thing,
when do I get the money back?
so the first thing that Sri said was an actor is an asynchronous process. Now, can someone tell me, how do we do multi-threading in LabVIEW? Anyone?
It's basically doing it automatically most of the time.
Yeah, absolutely. To do multi-threading in LabVIEW, put down 2 while loops. Good. They'll execute in different threads depending on system resources. So I'm going to start off with an actor is an asynchronous process. Asynchronous process in LabVIEW is a while loop. But there are a couple of rules. So an actor must be able to create new actors. And we know how to do that already. Or it might be a bit of a more advanced topic, but it's This is a common way of just launching asynchronous processes. Get a reference, start asynchronous, call, event, close your reference. Okay, so we know how to do that. We need to be able to receive messages. Well, we know how to do that as well. We can dequeue. We need to be able to make local decisions. Again, that's really trivial stuff. Case structure, depending on the data coming in, we make decisions about what we do. We can perform actions. So once we've decided what we're going to do, we can then do it. We process exactly one message at a time. Well, again, we're still doing that. We can only enqueue, dequeue one message at a time. We also need to be able to send messages. Great. So these are all things that we know how to do to start with. So things like the queued message handler, you could think of that as a single actor system. You could create lots of these QMHs, use them together, and bingo, you have a multi-actor system. The word actor comes from these loops behaving to do a particular job. So if we had a data logger actor, that asynchronous process is behaving like a data logger. It is acting as a data collector. We could have another one that's acting as a user interface. We could have another one that's acting as a message handler. And so we can build up this actor system. Again, this is just the actor model. You might already be doing this using the DQMH or the queued message handler or James Powell's messenger library, where we have a root actor. And remember the first rule, every actor must be able to launch other actors. So from the very top, root actor, that is able to launch a user interface, and it's able to launch business logic. If you remember my presentation earlier, that user interface was quite complex and there was a lot going on. And so I just want to separate that completely to all of my business logic. I don't want any coupling there at all. So I launched them separately. That business logic is built up of maybe file I/O and hardware I/O. And so you can very easily build up this actor tree. Although it's not a rule of the actor model, it's definitely highly recommended that your messaging systems follow these arrows. So where root actor, launched user interface, and business logic, you should only send messages up and down those arrows. And we call that communicating with a nested actor or communicating with your calling actor. This allows you to really nicely decouple items. When we create systems in LabVIEW, generally, we want low coupling and high cohesion. So low coupling is that this module here isn't dependent on any other module. High cohesion is, let's say that this user interface is really good at showing information, but it can't do anything else. It's rubbish at data logging, has no idea how to do that. So, actors in the actor framework. To launch our very first actor, well, that's all the code we need. That's, okay, there's a bit more to it than that. But with object-oriented programming, we can make anything an actor. Basically, in actor frameworks implementation of the actor model, we have a class here called actor. It's actor.lv class. And so long as you have a class that inherits from actor.lv class at some point, you could have an inheritance level going down, I don't know, 100 levels if you really wanted to. At some point, you need to have actor as an ancestor. By having actor as an ancestor, we are actually stacking the behavior. So in actor framework, your lowest level child class has all of the functionality and behaviors of its parent's class, and that has all of the behaviour of that parent's class, and so on and so on and so on, until we get to actor. When we launch a root actor, using that VI there, in the background, we are getting a static reference to actor.vi. We're getting a VI reference to it, but then we're starting an asynchronous call. Oh, that's not my easy. Okay. So that was rule number 1 that I showed you earlier. And this blue line, I'm just showing you that we are passing this actor model into this sub-VI, then it's actually connected to the VI which we're about to launch. This actor object, that could be a data logger, it could be a user interface, it could be a DMM, it could be collecting data, it could be communicating across a network, it could be absolutely anything. But so long as at some point all of those actors inherit from actor.lv class, we can use this framework. Okay, so we launch actor.vi. When we launch actor.vi, when we've passed in that object, so we pass in the object of the actor, which could be a data logger, let's say. We pass in this data logger into a VI called freelaunchInit. Now this is one of those VIs which we can overwrite, we can append functionality. So the data logger might want to create some references to files, or set up some files, or make sure the directories are all set up and working within freelaunchInit. It's like your startup VI. Okay, once that's all done, we could package all of those references into this cluster, into the object, and we start actor core. Actor core is just a while loop. It's a while loop that can receive messages. So we have a DQ function there. That's not what the actual function is called, but we can DQ exactly one message at a time that's being sent to that actor. And then the next VI along is called receive message. And inside receive message, we can execute any number of bits of functionality. So we DQ, and notice how we get some data out, which happens to be an object, and that gets put into receive message, where we're going to act on that object. Okay, so perhaps we've been using a QMH, where a typical message might consist of an enum telling you the state or behavior and a variant for all of your data. Well, we know that a class, well, more specifically an object in this case, is a whole host of methods and the data required to execute those methods. The same as an enum and the variant that goes along with that enum. We can just encapsulate that into this object. So instead of using a string and variant for QMH message, we can send an object. And so for every message in the actor framework, we actually have to create a brand new class. Well, that's all scripted for you, so we don't need to worry about the hard work there. Because a class has a name and it has all of the data required to execute that functionality. The next was making a decision. So with QMH, we might DQ this message, and so we get the message out, and we make decisions based off a case structure. Within object-oriented programming, we can choose an implementation of that object. So what we see here, we have, I don't know, let's say 30 different implementations here. think of that as 30 different cases in the case structure below. Okay, who's still with me? Okay, a couple of nods. All right, I'll take that. All right, let's do.
Just one question.
Oh, yeah.
That preview window, is that new in 2019?
Yeah. Mm-hmm.
That's really useful. I always found it impossible to navigate Actor framework, but that makes it, I think, much easier.
Oh yeah. The preview window is great. Yeah. Also, things in this preview window, you can use context help and like hover over a function, even though it's in the preview window, and context help will be
Nice.
in fact, I'm pretty sure you can right-click the block diagram as well and see your functions palette. Basically, this is the sub-panel, and there's a scripting tool you can enable to insert block diagram. Any other questions? Cool. Let's have a look at a demonstration. This one. Okay, the code I'm about to show you is available on my GitHub page. Again, there'll be a link later on. I thought I would show you this piece of code because it actually links in subpanels, which I was talking about earlier. And so this piece of code, all I'm doing is showing you that I can launch X number of actors. Every time I click launch chat window, I am launching another actor, another asynchronous process that's happening in the background. Now, instead of having 11 different actors just filling up my screen, I've put them all into this window here, and I'm changing the subpanel. And showing the VI that's being shown in this subpanel. So the user one status could be AI at UKTAG. And let's say user one wants to talk to user three. Instead of instead of swapping between 1 and 3, I'm just going to pop out number 3 and put it there, and send a message to user 1. So you can send messages between these asynchronous processes, and the code behind the scenes is surprisingly straightforward. Even though there's quite a few different levels of actor I've implemented here. All of these actors obviously need to be able to shut down. All of the actors need to be able to communicate in some way. So I can send a chat to every single actor that I've launched. I can also gracefully stop every single actor. This is what the code looks like behind the scenes. So in Actor Framework, an actor is a library, and inside that library we have a class, and inside that class we have a couple of methods. So we have a method here called enable controls. We're only going to execute this method once there are people to talk to. So you can see that it's disabled at the moment. If I run it, if I launch an actor, you can see that enable controls must have executed because now I can send a global chat. Each of those methods, I can right-click, go to Actor Framework, and create a message. And that's going to do all of the hard work that I was talking about earlier regarding making messages for the actor. By right-clicking and going to create message, it will create the class that I need to send. And I can send the class, I can send the message event, the do VI, is what's going to happen when that message is received. Now, as I said, I'm not going to go into how to create actors or really dig down deep into the code, but I hope this has been an eye-opener into object-oriented programming and what actor-oriented programming is. So now at least when someone starts talking about, oh, I have these actors and they're playing up, or talk about actors, you know what they're talking about. Couple of resources to actually get started in using actors in the actor framework. Well, I have a YouTube channel. In this YouTube channel, I have a couple of playlists. The two that I'm showing on the screen here are Introduction to Object-Oriented Programming. There's another playlist of LabVIEW Actor Framework, where I go right from the beginning of a recap of modular applications in LabVIEW, how we derive the actor framework, creating a hello world example, all the way through to what I showed you today of subpanels and how we can send things like abstract messages and more complicated items in AF. All of the code I've shown you today and all of the code I demonstrate on my YouTube channel, you can find on my GitHub page, Tom's LabVIEW Adventure, well, github.com/Tom's LabVIEW Adventure. You can download it, and it's all there. Various training courses. There's an active framework course running in August. I may or may not be teaching that one. There is an OOP course. I haven't seen that publicised recently. There may or may not be one of those. I may or may not be teaching it if it does. Cool. And also the Active Framework forum page, ni.com/Active Framework. Loads of great resources there as well. Okay, so for my our giants are female, I want to talk a bit about the work I do as a STEM ambassador. Because I go into lots of schools in the local area and I talk about what I do as an engineer. I talk about what engineering is. You can see here I talk about learning from nature. I'm actually talking about a little frog here and how that uses engineering techniques to amplify its voice. So this is something I really like to do because I can see all of these children really engaged and really enthusiastic about asking questions about climate change. Asking this girl here, who I'm going to pick as my Giants Are Female nomination, she constantly had her hand up asking questions about electric vehicles and electric planes, when we're going to start seeing them, whether we should carry on flying. All of these children were acutely aware of the shortage of STEM skills we have, so science, technology, engineering and mathematics, skills that we have in the UK. And I know that when I was going through the education system, I had people coming into my schools to talk about engineering, and that really motivated me to become an engineer. So I want to put it to you that if you like the idea of promoting STEM, if you like the idea of going into maybe schools or colleges to do presentations, or perhaps just even judging a competition, then have a look at STEM Ambassador UK or STEM Learning, or contact me directly. So that's call to action number one. If you're interested in promoting STEM and promoting STEM to these young children and actually doing something about the shortage of diversity within STEM, then please come and talk to me. Come and talk to me anyway. But, the second thing I want to talk about is I've been working a lot with the IET recently. so the Institute of Engineering and Technology, about neurodiversity within STEM. And so looking at things like dyslexia, dyspraxia, dyscalculus, and many other neurodiverse issues. Within the IET, we're trying to promote and gather lots of case studies about people who didn't really fit into the education scheme that we have in the UK, but also worldwide. And try and get lots of case studies together. So action point number 2, if you have a story to share about becoming an engineer, please come and talk to me about that as well, because we're trying to get case studies together for the IET. Okay, so that's it from me. Please like, comment, and subscribe to my YouTube channel, Tom's LabVIEW Adventure. You can find me on LinkedIn under Thomas McQuillan. If you're on Twitter, you can twitter me at TomMcQ93. All right, thank you everyone.